In this demonstration, we're going to take a brief tour of TamoGraph Site Survey. Now, we're using this for predictive design at this time, so we're not really worried about the survey features, but know that this tool, like the others, like Ekahau Site Survey, Air Magnet Survey Pro, and IBWave Wi-Fi, can indeed do a survey where you walk about and gather metrics or data from a wireless LAN, both active and passive. But we're focused on design, so let's start a new project and see how this works. We'll click on New Project, and I'll just call it Test. And we could enter a description, which is a good idea for a new project you're creating for a true wireless LAN design. We'll click on Next, and then choose the environment type. Now this tool provides us with 6 environment types, 3 indoor and 3 outdoor. And the indoor can be high attenuation, medium attenuation, or low attenuation, and the outdoor is the same. We're just going to go with an indoor medium attenuation in this example. The guess range is for when you're doing a survey, and we're not doing a survey, so we're not concerned about that. But if you want more information on that, you can press F1 and look at the help. It'll tell you a little bit more about the guess range. And this tool is available as a trial version that you can download to work with. You can set your measurement units in feet or meters. I'm going to leave it at feet and click on Next. Then set your scanner. We're not doing any scanning, so we're not worried about that. So we're just going to accept all of the defaults here. And I need to load an image. This is a floor plan image. So we'll select Load Image, and notice the image types that are supported includes DWG, DXF, DWF, so it does include CAD drawings. In this case, I'm going to use a JPEG image of a floor plan, which will require that I draw walls and so forth. So we'll double click on the image and then click on Next. It says, great job, you're ready to start your design. So we'll click on Done. And so that's the beginning point. But one of the first things I need to do is calibrate my image, because if I don't calibrate it, then it's not going to do predictive propagation appropriately. For example, let's go ahead and click on Start Calibration of Current Sitemap. And then I'm going to click and drag right here, which my floor plan tells me is a 10-foot section or distance, right? So I've chosen that width that is supposed to be 10 feet. And I'm going to say that it's actually 40 feet. And click Apply. Now I'm going to put an AP on here. So we'll just select a generic 802.11ac AP in 5 gigahertz. And we'll click on the map to place the AP. So we've now placed the AP, and let's take a look at a signal level heat map, for example. And I've got my visualization quality set to low or fast. If I set it to best, it's a little more granular, it's a little more detailed, but it's a lot slower when you're doing your updates. So right before you render any graphics, you might set it to low and to best and slow, but during moving and things like that, you probably want to adjust it. So just note the coverage that I'm getting there. And now I'm going to recalibrate so that this is actually the 10 feet that it's supposed to be. Click Apply. And now notice how much bigger my sunburst is, if you will, with the propagation around it, because it's accurate. The calibration is accurate. And so that's a very important thing to do. First thing you want to do is calibrate. And I'm going to delete that AP. Once you've calibrated, you can start drawing some walls. So what I'm going to do is go ahead and get my perimeter in place all the way around this building. And I've got a brick wall. We'll say it's a 9-centimeter brick wall in this case. Note that you can manage these presets. So you can go in and adjust the attenuation and reflection patterns for 2.4 and 5 gigahertz. You can create your own new materials and so forth. In this demonstration, I'm just going to use the built-in example materials. So I'm going to go ahead and go with the brick wall. And what I'm going to do is make sure that I'm in polygonal path mode. And so I click, go to another corner and click, go to the next corner and click. And I'll continue this right around the outer edge. And I'm not worrying about windows. Normally, you definitely want to do that because they're different materials, right? So there we go. I've got my outer walls, and that's going to impact propagation. So for example, if I go back and put an AP on here again, and then I take a look at the signal level, notice the flattening and the effect that that wall is having. Okay, it is going to have an effect. It's got reflectivity characteristics. It's got absorption characteristics. So that outer wall is important, not just my internal walls. Now, the next thing I want to do, I'm going to go back to none for visualization and just delete that AP again, is I want to draw my internal drywalls. So I'll just choose interior drywall. And right inside of this out wall, I'm going to put drywalls in here because guess what? We have internal drywalls inside of our external brick wall. So I'm just going to draw them rough. Normally you would want to zoom in, get very detailed in this, but I want to just demonstrate to you really the impact and making sure that you have your walls in place. So there's some internal drywalls. And now I'm going to go ahead and draw another one right across here. I'll draw one right across here. Right up to here. And we'll hit escape to indicate that we're done with that. And now what I need to do is draw in line mode, just single walls right up the middle in between each of these offices. Again, zoom in if you need to, draw them carefully. We just want to get some walls in place very quickly so we can see how it impacts propagation. Make sure you test and know what your walls are, as we've talked about elsewhere, because this might be some type of a concrete wall between these two restrooms, and you want to know what those walls actually are. You want your doors to be closed as well. So even if you're drawing a wood door instead of just surrounding it with drywall like I am, make sure that they're drawn closed instead of being open like they might be on the floor plan, because you want to be designing for that scenario where they might be closed, and that's going to impact RF propagation. Now, I'm not going to draw the rest of these walls down here because I want you to see the difference between the area below and the area above based on these walls existing. Now, what I also want to do is set my coverage and deployment area, and I'm making sure I'm in polygon mode. And once again, I'm going to indicate that it's basically this whole area here that I want for coverage and deployment. So everything basically inside of my brick walls. That's what I want to cover. Okay, so I have my coverage and deployment area, and you can always go up to view and deselect different things if you don't want to view the virtual objects, such as AP auto placement areas, floor areas, things like that. And when you turn them off, they're just not there visually, but they're there. You can even make it so that you don't see your walls and you're just looking at the floor plan, but know that they're going to impact propagation. So now what we can do, since we've got all of that specified, is we can go to the RF planner and auto place APs. Now, I would recommend using auto placement of APs because it makes your life easier getting some APs on the floor plan, but I would suggest that you know that you're the expert and you're going to move APs, delete APs, maybe even add more APs in some instances. So make sure that you consider that. In this tool, because I'm not defining different coverage areas that have different requirements for clients, I can't use advanced. I haven't done that. We'll just go with simple capacity and click next. And you can choose 2.4 gigahertz and what you want the power level to be. I'm going to say I want my 2.4 gigahertz to be at 5 milliwatts. And I'm going to say that I want my 5 gigahertz to be at 10 milliwatts. Okay, so I'm just choosing those numbers. You have to do what you need to do for your specific design. Set the height of where these APs are going to be, the antennas / APs are going to actually be, and decide if you want some 2.4 gigahertz radios disabled to reduce CCI. Click on Next and choose the channels you want for 2.4 and 5 gigahertz. So you can pick whichever channels that you're going to say you want to use. And then click on Next. And then what is your number of APs that must provide coverage at each point? So maybe for some reason you want 2 in 2.4 gigahertz at -70, and you want 2 in 5 gigahertz at -65. This comes from your specifications when you're defining requirements. Click on Next. And then do you want standard or high precision, which is going to take a little longer. We'll go ahead and go with high precision, even though this is a small network, and click on Done. So it's going to go through and place my APs. And so we can see the APs that it has chosen to deploy. Now that I have some APs deployed, I can go in and look at the results. So I can say, what about my signal level in the space? I can say, what about my AP coverage areas? My number of APs. So this is telling me how many APs I see at each location. Notice I see more than 5 in many, many locations. Now, right now I've got 2.4 and 5 gigahertz. Let's disable the 5 gigahertz and see what I've got. Now I've got more than 5 in many locations, which is going to be a lot of CCI. So I might want to go through and make some adjustments. But I've also got some areas where I only have 1 or 2. And now I want to evaluate that and see what kind of adjustments I might want to make as well. So you can see then with a tool like this one, how I can get it up and running, get in my floor plan, calibrate it, place APs, and then possibly make adjustments to the APs. Note that up here, I can see visualizations are applied to all APs or visualizations are applied only to selected. And that's why when I deselected 5 gigahertz, I was actually able to accomplish the result that I wanted. And I can deselect some of these to see how it impacts my number of APs seen. Finding the 1 or 2 that I might want to disable in order to get what I'm actually after in my environment, if I want to go in and disable some of those 2.4 gigahertz radios. Same thing with my signal strength. So here I see my signal level, and I can go through and disable some of these 2.4 gigahertz APs to find out which ones I might want to disable in order to reduce CCI within my environment. So this is one tool that I can use for wireless LAN design.